Hey, Sarah, we'll wait a minute or two and see if anybody else shows up. Hopefully they do. It's not much fun with just one person. So I know 4 or 5 other people said yes. So hopefully we get some participation today.
Okay.
Here we go. Hi, Mary. I was just telling Sarah we're going to wait a minute or two and see if anybody else shows up.
Sounds good. How are you doing?
I'm doing pretty good. How about you?
A little sleepy, but okay.
It's 2 p.m. That is like, you know, my sleepy time. But luckily for you guys, I got up and walked around before this meeting. Otherwise, I'd be boring you to tears.
No, I think it's just all the rain today. It's the perfect day for a nap. So.
Oh, I agree. It has been so drizzly and dreary and just blech. Blech. Okay. So while we're waiting, let me pull up my PowerPoints here. Well, thank you guys for coming on an off time. I apologize about the Zoom snafu yesterday. That ruined my whole day. I had plans.
Yeah, I heard a lot of people, their Zooms were all crashing. So I don't think you're the only one.
Yeah, it wasn't just Georgia Highlands. The whole Zoom platform in the Southeast went out.
Gosh.
Which, like I said, really totally messed me up because I had a great lecture planned. We were going to jump into our breakout rooms and we were going to have fun. And then they're like, just kidding. No lecture. Hey, Will. Okay, guys, so let's go ahead and get started so we don't have to be here forever. I know you guys are tired. I'm tired. So shall we just jump right in and get to it? So we're going to talk about dimensional analysis today, which in the old textbook, before we switched to atoms first, was really, really important right away in the whole like first half of the course. And then you got to the second half of the course, which was the non-mathy kind of stuff, where you didn't really use it so much. Of course, now we've switched to the atoms first model, and it's kind of the opposite. So we're going to cover dimensional analysis in this chapter. And then we're not going to touch it very much for the next 4 chapters. And then we're going to get to the end of the semester. And when we deal with chapters 6, 7, and 8, we're going to use it all the time. So it's kind of a bummer because you're going to use it for this first exam, and then you're not going to use it, and then you're going to use it. But it is a skill that's really important. It's something they teach in algebra. It's something that they utilize in most of the other sciences, not just chemistry. So I feel like it's a really important topic, and I hope that you guys find it as kind of fun and interesting as I do. So I'm going to share my screen. Okay. And just so you guys know, this is being recorded. And when I pull these PowerPoints up here in a second, I won't be able to see the chat feature. So I know Mary and Sarah, you both have microphones. Will, I don't know if you have a microphone on your computer, but if you do need to type questions into the chat, if somebody could just let me know when the questions come up, because I won't be able to, once I'm in the PowerPoint slide, I can't see your questions in chat. Oh, and of course, before I forget, due dates. I always try to start every lecture with a reminder about your upcoming due dates. So this is not your D2L shell, of course. Okay. So upcoming due dates, if you go to content, my internet's slow. If you go to content here, and then you click on course schedule, full schedule, it'll show you all of the due dates, all the things you guys have coming up. So let's see here, we're past that. We are past Monday. So on Wednesday, you guys have a reading due and a course ticket due. And as soon as we're done with lecture today, I will post the course ticket. Course tickets typically take about 5 to 10 minutes to complete. They're pretty short, and they will be posted in the unit. So your course ticket 1.2 will be in unit 1 under the bucket called course tickets. And you submit it here through this link. So again, on Wednesday, tomorrow morning, you have reading 2.1 through 2.2 due and your course ticket, which should only take you a few minutes. You've also got a homework assignment due this Sunday night, 1.3 and 2.1. And so please don't forget that as well, 1.3 and 2.1. And then as you see, you know, as we go down, you've got more readings due. We've got quizzes coming up, labs coming up, all that good stuff. So anytime you want to just take a look at the schedule, click on content, course schedule, full schedule, and you will see all of the due dates that you have coming up, as well as links to where that assignment is located. So you never have to remember where to find an assignment. Okay, so let's switch over to lecture. Okay, and again, we're going to be talking about dimensional analysis today. You might also have heard this called the factor label method, depending on if you've seen this before. Sometimes in grade school, they call it the factor label method. I don't care what you call it. All I really care about is, do you know how to do it? Okay. So the dimensional analysis method is used to convert units back and forth and solve problems. It's a technique that we're going to use often. And again, as I said, we're not going to use it too much in chapters 2, 3, 4, and 5, but 6, 7, and 8, we're going to use it a lot. It's also called the factor label method because it factors out or cancels units. And our goal is going to be to travel from whatever unit we're given to the unit we want to get to. Okay. And how are we going to do this? Well, we're going to look for something called an equality. And we're going to take that equality and turn it into a conversion factor. Okay. Equalities are two measurements that are equal to each other. And believe it or not, you know hundreds of equalities. And so my question to you is how do you recognize an equality in a word problem? Well, you're going to look for words like per, each, every, equals, right? Those kind of words indicate to you that you have two measurements that are equal. So for example, 1 hour is equal to 60 minutes. So you might see something that says there are 60 minutes for every hour. So there's that word every, right? 60 minutes for every hour indicates that 60 minutes and 1 hour are equal to each other. Or you might see something like, my speed on the highway is 60 miles per hour. That per tells me that the 60 miles is equal to 1 hour of travel time. So for every hour that I travel, I will go 60 miles. Okay, that's an equality. So whenever you're dealing with a word problem, you might find that they give you some information. Now, there's a lot of equalities out there that you're not going to get in your word problem. And those are things that we just kind of expect that you know off the top of your head, like 1 hour equals 60 minutes, right? Or 24 hours is a day, or 365 days is a year. Although actually it should be 365.25 days is a year, but you get what I'm saying, right? Things like if you grew up in America, we would expect you to know there's 12 inches in a foot, you know, 16 ounces to a pound. Those kinds of things you probably won't be given in a word problem. But there are hundreds and maybe even thousands of equalities that you won't necessarily know off the top of your head. And those are the kinds of things that you either have to look up somewhere or you'll be given in the problem. And again, if it's given to you in the problem, you're going to be looking for your keywords so you can tell what the equalities are that are specific to that problem. If you're looking them up, if it's something you don't know and you're not given in the problem, right, often your best bet is some sort of reference table. So in your textbook, there's in the appendix, right, there's usually references given there that tell you oftentimes the conversions between the English system and the metric system. So like the back of your book will tell you that there's 2.54 centimeters in an inch, or it'll tell you how many kilograms in a pound, that kind of thing. You can also Google it, although I really don't recommend that as a method. Your best bet is to actually look it up in a reference book, like a textbook, a lab manual, that kind of thing. The reason I don't generally recommend Google is you may not get necessarily an accurate answer. And unless you know how to look for a reputable website, you may not get an answer that's a good one. Okay. So let's see how this works in an actual word problem. Okay. In this word problem, it says you are traveling 65 miles per hour down the highway. How long will it take you to get from Atlanta to Knoxville if Knoxville is 155 miles away? Now, I don't want you at the moment anyway to actually solve these problems, right? And there's the next one says if there are 3 feet in a yard, how many inches are there in a standard 100-yard football field? And then there's another one about James Patterson. I don't want you to actually solve these word problems. What I want you to do is to find the equalities in the word problem. So if you're looking at these word problems, what are the measurements that are equal to each other? Okay, so take a minute and just kind of read through these 3 word problems here and see if you can pick out the equalities. And again, you're looking for words like per, each, every, right? Equals. So see if you can look at these word problems and see if you can pull out all of the equalities that are in there. And so I'll give you guys a minute to do that. I'm not going to put you in your breakout rooms yet. We'll do that when we get to the actual problem solving. Okay, let's take a look and see how you did. All right, so looking at the first problem, it says, let's go back to the original problem here. You are traveling 65 miles per hour down the highway. How long will it take you to get from Atlanta to Knoxville if Knoxville is 155 miles away? So the only equality that we're given is that we are traveling 65 miles per hour. That means that for every hour traveled, we will go 65 miles. So that is our first equality, that 1 hour is equal to 65 miles in this particular problem. Okay. Hopefully you guys picked that out. Now let's go back to the next problem. If there are 3 feet in a yard, how many inches are there in a standard 100-yard football field? Okay. And again, this particular problem gives us one explicit equality, and that is that there are 3 feet in 1 yard. So the explicit equality in this problem is 3 feet equals 1 yard. And hopefully we also know, if you grew up here, hopefully you also know that 12 inches equals 1 foot. Now that 12 inches equals 1 foot was not explicitly given in the problem. The 3 feet equals 1 yard is what we were given. Okay. And then problem 3 says, on average, there are 3 pages in every chapter of a James Patterson novel. Each book has approximately 79 chapters. James Patterson has published 58 books. Approximately how many pages has he written? There are 2 explicit equalities given in this problem, and they're indicated by the words every and each. Okay. So problem 3, 3 pages is equal to 1 chapter. And 1 book is 79 chapters. So those are the 2 explicit equalities that are given in that problem. And this is definitely a skill you guys want to practice if you have the chance, right? Looking at word problems and being able to pick out the things that are equal to each other. It'll make your life a lot easier when we get to the section where you actually have to do, right, multiple problems. Okay. So now, how do we use that to do this dimensional analysis thing? Okay, how do we use that to do this dimensional analysis thing? What we're going to do is we're going to use something called a conversion factor. And a conversion factor is basically taking your equality and turning it into a fraction. So our goal in the first problem was to determine how long it will take you to get from Knoxville to Atlanta if you were traveling at a steady 65 miles per hour. So we need a conversion factor that will turn the distance, 155 miles, into a unit of time. There we go. So again, we said that 65 miles was equal to 1 hour. Okay. If we divide both sides by 65 miles, right, we cancel it out and we see that 1 hour divided by 65 miles is equal to 1. And so that is a conversion factor. Right? A conversion factor is something where you have two equal measurements, right, and you have them in a fraction form. Okay. Not done this on Zoom before. I've got to keep kind of moving our faces around so I can see what I'm doing. And so now we have created this conversion factor here. And my question to you is, could we create a second conversion factor from the same equality? So my equality again said that 65 miles equals 1 hour. Out of that, we got the conversion factor 1 hour divided by 65 miles. Could we get something different? And the answer is, why are you being a butt? Ha. The answer is yes. For every equality, you can get two conversion factors. Every equality produces two conversion factors. So anytime you have two things equal to each other, you can write it with one thing on the thing A on the top, thing B on the bottom, or thing B on the top, thing A on the bottom. And this becomes important when you're converting things and you're not told, what order to use them in. Okay. So again, dimensional analysis in practice. You have a starting point, which is your given unit. You have an ending point, which is the unit you want to get to. You have your conversion factors that you have created from your equalities, and you have to decide which one do you use. Well, units can cancel just like numbers can. And so we want to basically get rid of the unit we have, miles, and end up with a unit of time, right? We want to get rid of miles and end up with a unit of time. Our starting distance was 155 miles. Okay. We had an equality that said that 65 miles was equal to 1 hour. So in dimensional analysis, when we want to get rid of something, you want to put it on the opposite side. So miles is currently on the top left. In order to cancel it out or get rid of it, it needs to be here on the bottom right. Okay, so in order to cancel it, we need it on the bottom right. Okay. So we're going to use the conversion factor that has miles on the bottom, because then when we put it next to our 155 miles, now my miles are going to cancel out. And I'm going to be left with a unit of hours. Okay, so again, our starting point was miles. We wanted to end up with hours. We're going to take the equality that we pulled from that word problem, and we're going to write it as a conversion factor. So we're going to turn it into a fraction. And then the one that we choose depends on what we're getting rid of and what we're trying to get to. Okay, so my question to you guys is what does this symbol refer to? And hopefully you guys recognize this symbol as division, right? It's the universal symbol for dividing something. Well, anytime you're dealing with dimensional analysis, right, this horizontal line here indicates division, okay? Any of these vertical lines here indicate that you are multiplying. So whenever you see dimensional analysis, the vertical lines indicate multiplication. These horizontal lines here indicate division. So what this is saying is 155 times 1 divided by 65. So if we pull out our calculators, and and type this into our calculator. Okay, we have 155 times 1 is 155. Divided by 65, I get an answer of 2.4 hours. Okay. So let's try this again. Okay. We want to convert 100 yards into inches because that's what our question asked for. So my starting amount is 100 yards. I want to get from 100 yards to inches. Now, we pulled out the equality that 3 feet equals 1 yard from our word problem. We pulled out the equality 3 feet equals 1 yard from our word problem. We also said that we know, if we grew up here, we know that 12 inches equals 1 foot. So our goal is to get rid of these yards and end up with inches. Now, our first equality, 3 feet equals 1 yard, can be used to get from yards to feet, right? That's how we're going to go. So what we're going to do is we're going to take the yards that are on the top left and we're going to put them down here on the bottom right to get rid of them. So 3 feet, 1 yard. Okay, this enables my yards to cancel out. Now, to get to inches, we're going to use the equality that was not given in the problem, but we know in our heads. We're going to use 12 inches equals 1 foot. And again, feet are on the top left. So in order to get rid of them, they need to be on the bottom right. So 12 inches is 1 foot. This enables my yards to cancel and my feet to cancel, leaving me with inches. Okay. And again, to type this into your calculator, right, we've got multiplication, and then these horizontal lines here mean division. So in your calculator, this is saying 100 times 3, okay, 100 times 3 is 300, divided by 1. Right, 300 divided by 1 is just 300, times 12, divided by 1. Okay, so I get an answer of 3,600 inches. So 100 yards, or a standard football field, is 3,600 inches long. Okay. All right, last one. Okay, the last one, our goal was to convert the number of books that James Patterson has written over his lifetime into an approximate number of pages, right? How many pages has he written in his lifetime? Now, we know that according to the problem, he wrote 58 books. And we pulled out of the problem 2 equalities. We said that 3 pages equals 1 chapter, and 1 book equals 79 chapters. Okay, so again, we pulled out the equalities, 3 pages equals 1 chapter, and 1 book is 79 chapters. Now, we want to get rid of the books, right? We want to get rid of books and get 2 pages. Of the 2 equalities that we pulled out of that problem, the only one that mentions books goes from books to chapters, right? 1 book is 79 chapters. So again, book is on the top left, so I want to put it on the bottom right in order to get rid of it. So 1 book is 79 chapters, but I don't want my answer in chapters, I want my answer in pages. And again, the word problem told us that 1 chapter is 3 pages. We got that from that word problem. So chapters are on the top left. I want to get them on the bottom right. Okay. So now my books cancel, my chapters cancel, leaving me with pages. And this tells me that I am going to take 58 times 79 divided by 1. So 58 times 79 divided by 1. Okay. Then that answer times 3 divided by 1. And I discovered that James Patterson wrote in his lifetime 13,746 pages of novels. Okay. So these might seem a little bit simplistic, but it's really important to get the technique down. Okay? It's a tough kind of thing to do on a test to say, oh boy, you know, here's this bunch of conversion factors. Like, how do I use this word problem and solve it, right? And so what I want you guys to get comfortable with is picking out conversion factors, right? Picking out equalities from a word problem and turning them into conversion factors, and then using them to do dimensional analysis to solve a problem. So if you guys want to hang around, I've got some problems you can practice on. Okay, I don't know how you guys feel, but it's a small group today, a really small group. So why don't you guys talk to me? How do you want to work on some problems? I've got some practice ones. I can put you in a breakout room and you can work on some problems, and then we can come back and talk about them. How do you guys? What's the feel of the class right now?
Yes.
Yes. Okay. Other votes? If you don't have a microphone, you can type in the chat.
I think it would help.
Awesome. Awesome. Okay. So what I'm going to do, guys, I'm not sure once I put you in the chat room or the breakout room, if you're going to be able to see my screen or not. So I'm going to put you guys in the breakout room. Then what I'm going to do is I'm going to go into D2L in unit 1, and I'm going to post the problems so that one of you or all of you on your computer can see the problems you're going to work on. Okay. Will that work? Yes. Do you guys all have, are you guys on laptops?
Yes.
Are you able to? Okay. So that's what I'll do. So I will, because I'm not sure if you'll be able to see my screen or not. I'm going to stick you guys in your breakout room, and Eli, that's okay. I know you have to leave. I'm stick you in your breakout room. You guys can unmute your microphones. You can all talk. And then what we'll do is we'll go for 10, 15 minutes. Then we'll come, you guys can check in with me. We'll work the problems together. We'll make sure that you're getting them right. And then if you still want to do more, we'll pull up a few more. Okay. So I'm going to put you in your breakout rooms, and then give me 5 minutes to get them posted. Okay. I'm going to post them in the lecture folder, chapter 1 in D2L. Assign 4 participants in the 1 room. Okay. All right. So you should all have been invited to join your breakout room. Come in. Oh. I mean, they're in their breakout rooms right now.
Oh, I'm sorry.
Okay.
No, I'm not normally late. Zoom was down yesterday.
Oh, that's right.
Yeah,
So
that's
we're
okay.
trying the breakout rooms today to see
How
how it's
was
gonna
that?
work. That was good. Okay. So if you're watching this recording, the students who've attended today are in their breakout rooms. They're practicing the problems that are in D2L under the lecture folder called Dimensional Analysis 1. I'm going to give them 10 minutes to work on the problem, and then we're going to come back from the breakout room and work on the problems together. So if you're watching this video, you may want to fast forward about 10 minutes. And then come back. I do strongly suggest if you're watching this video that you practice, pause the video for 10 minutes or mute the video for 10 minutes and just practice the problems so that when we come back in 10 minutes and I pull the students out of the breakout room, that you will have also tried the problems. And this is a skill that's really important. Okay, I'm going to be quiet now and I'm going to set my timer for 10 minutes. How do I set a timer? Ooh, I figured it out. 4 minutes, 7 minutes, 8 minutes, 9 minutes, 10 minutes. Oh, where's my timer? I should probably pull it. Why can't I put a damn equation? Hey, Mary, we're just waiting for everybody else to come back over.
Sorry, I accidentally clicked out a bit early.
Oh, you did? How did it go? Did you guys like the breakout room? You were able to talk without me kind of eavesdropping?
It went okay. I've been homeschooled my whole life, so like group settings are kind of like throwing me off a little bit, but I mean, it worked out well.
How many problems did you guys get through?
Together we got up to number 5, I think it was.
Oh, wow, you guys did pretty good then.
Yeah, so not too shabby.
Yeah. So we'll just, like I said, we'll wait. They've all been notified to come over. We'll wait till everybody else gets over here and then we'll talk about them.
All right, that sounds good.
Awesome. Here's Sarah and Will. Okay, so let me close this out for a second. So I was just asking Mary how it went. What do you guys think? Did the breakout room work okay? Were you guys able to get through some problems?
Yes, it's helpful.
It's helpful. Awesome. Then we'll keep it going forward because the problems there's lots of problems built into the rest of the chapter and there's more and more of them kind of as the material gets more dense. So I'm glad to hear it. Okay, so Mary said you guys got through what, about 5-ish problems or so? Is that about right?
3.5.
3 and hey, that works, so let's go ahead, let's talk about them. So I'm going to share my screen. Hey, that way we can, oops, I did not want to share the PowerPoint. It's not what we're looking at here. Okay, so can you all see this? This was hopefully the set of problems that you guys were working on. Is this correct?
Yes.
Yes. Okay, awesome. So I kind of started out the first one. So our starting unit on this first one was 10 kilometers. And what we wanted to get from kilometers to miles, right? And we know that by the how word here, right? That's our question word. So we wanted to go from kilometers to miles. So what I did was, to solve this problem, I went up here to the conversion factors that I was given, and I looked for something that had kilometers and miles in it. And this is the one that I found. I found this one here that had both kilometers and miles in it. So I set up my problem using my dimensional analysis, and I put my kilometers, since that's what I wanted to get rid of. I had them here, right, on the upper right-hand corner here. So to get rid of them, I put them down in the bottom right. Okay, so it was upper left to bottom right. And then that cancels out my kilometers and leaves me with miles, right, which is what I wanted. Now, mathematically in my calculator, that means I did 10 times 0.621, and then I divided by 1. So what did you guys get for an answer on this?
I got 6.21 miles.
Awesome. Yep, that's exactly what I got, 6.21 miles. Okay. All right, let's talk about the next one. So to do the next one, I would have set it up the same way. So if I'm going to insert an equation here, I'm going to start with my fraction. Okay. My starting unit was 250,000 miles. Oops, I want that in black. Not red. Okay. All right. I don't know why that's red. Whatever. 250,000 miles. Now I want to get rid of the miles. Okay, and my goal is to get from miles to feet, right? And I know that because of my how word, right? So that tells me what I'm trying to do. So go back here. So we're going to look for another fraction, right? And I'm going to look for one that has miles and feet in it. So we used miles to kilometers in the previous one. Right, miles to kilometers in the previous one, but now we want one with miles and feet in it. So if I look here, if I look through this, I see that this conversion factor here has miles and feet, right? It tells me that 1 mile is 5,280 feet. Now remember that my mile is up here, right? It's up on the top left-hand side of my equation. So why is it doing that? So in order to get rid of it, I want it on the bottom right. And so I'm going to put 1 mile down here on the bottom. On the top is the unit I'm trying to get to, and I know that that is 5,280 feet. Okay, this enables me to cancel out my miles. Okay, there's miles, miles, and miles are canceling and leaves me with feet. Now, again, mathematically in my calculator, this is telling me to take 250,000. My calculator was actually on. 250,000 and multiply by 5,280. Now I put my answer into scientific notation because it was a really long number. I don't know how you guys wrote it, but what did you guys get for an answer?
We got 1.32 times 10 to the 9th power.
Yep, that's what I got as well. So you guys did scientific notation as well. Oops. I love the equation editor, but sometimes it's a pain in the butt. Into the 9. Oop, and I forgot my unit. And that is feet. Okay, so next one. This one has gallons as our starting unit, and we want to get to cubic meters. So again, we have gallons as our starting unit, and we want to get to cubic meters. So in my setup here, I'm going to pull out my equation. Okay. My starting unit is gallons, 10,000 gallons. Okay. And I want to get to cubic meters. Oops. There we go. So I'm going to put my fraction in here. Dang technology. Okay, so I'm going to put my equation. Put it here. So I want a conversion factor that will have gallons and cubic meters. And I know that no matter what, I'm going to have gallons down here on the bottom right. So again, I'm going to come up here to my list of conversion factors. Okay, and I'm going to look for one, if possible, that has gallons and cubic meters. Okay, that's my goal, is to find something that has both gallons and cubic meters. So coming through here, there's no gallons in the first column, no gallons in the second column. We have a gallon in the third column. The first one is liters. That's not particularly helpful. Let's keep going. Oh, here we go. 264.2 gallons is equal to 1 cubic meter. So this conversion factor will get me from gallons to cubic meters. And again, I want to get rid of my gallons. So 264.2 gallons is going to go on the opposite side. And then that means that 1 cubic meter is going to go here on the top. This now means that my gallons, right, these two right here are going to cancel, leaving me with cubic meters. Okay. And again, mathematically, what this means is you're going to take 10,000 and you're going to multiply by 1 and then divide by 264.2. So putting this into my calculator, 10,000 times 1 divided by 264.2 gives me an answer of 37.9 meters cubed, cubic meters. Okay. Is that what you guys got?
Yes, that's what we got. The
That's
only
what you
thing
got.
is I
Awesome.
put in 37.85 meters. Would that be I mean meters cubed, would that be wrong?
No, so
If you
you
had
might lose a little
4.
bit for for sig figs. Although actually I didn't do the right sig figs either, because if you look at this, our answer should have had what, 1 significant figure and I did 3. So I mean, honestly, the answer really should have been,
Oh, 40? Oh,
yeah.
okay.
I wasn't really paying
So,
attention to sig figs
okay.
either. But yeah, on a test, so that's a great question. Like on a test, I would definitely be looking at your sig figs to make sure that you're getting at least in the ballpark of the right. I'm not super picky, but if the answer should have, 1 sig fig and you gave me like 5, you would lose 1 point, basically is what I do. So for example, on a math problem like this, it might be worth 5 points. You would lose, if you gave me the correct answer but the wrong number of sig figs, you would lose 1 point.
Okay.
Same thing for units. If you just wrote down 40, or if you just wrote down, say you just wrote 37.85 with no units, you'd lose a point
Right.
for that.
Right.
But
Okay.
you would never lose credit for the whole question. I would never take off for the entire question because you didn't have the right number of sig figs, or you didn't round exactly the same way that I did.
Gotcha.
I'm more interested in, do you know how to do, like, how to solve the problem? I mean, like I said, I take a little bit off, but not for the whole problem. Okay. Do you guys want to do a couple more? We've got a couple more in here, and I know you didn't get through all of them, but so hold on, let me stop sharing here for a second. Do you guys want to go back into your, now you've seen a couple more of them worked out, do you want to go back into your breakout room and work on some more on your own? Do you want to go through more with me? How do you guys kind of want to do some more of these?
Go through them with you.
Is that the consensus of everybody?
Yeah, that works. That's fine.
Okay. All right, let's do a couple more. Let me share my screen again. Do you, before you go through them with me, do you guys want a few minutes, not necessarily in your breakout room, but just on your own to try a few more? Because it doesn't really do you any good to just watch me doing them. And I know you guys only got through about 3.5-ish problems.
Yeah.
All right, so here's what we'll do then. If you guys don't want to go in the breakout room, that's fine. If you want, what I'll do is I'll set a timer. What do you guys want? 5 more minutes, 10 more minutes? We got lots of time. You want me to give you another 10 minutes and then we'll come back and work several more?
I have to go at 3:30, so 5.
All right. All right, so we'll do that. I'm going to set a timer for 5 minutes. I won't stick you in the breakout room, but I'll set a timer for 5 minutes. You guys keep working, and then we'll, in 5 minutes when this goes off, we'll go through some more, okay? Set the timer. 5. Okay, 5 minutes. If you're watching this recording, you should be working problems during chapter 1 lecture. Okay, that's the timer. Alrighty, everybody ready to go over a couple more?
Sure.
Yep.
Okay, so let me share my screen. Okay, dimensional analysis. So we left off here. Okay, so let's tackle the next one. The average American student is in class 330 minutes per day. How many hours per day is this? So our starting unit is going to be this one here, 330 minutes per day. So let's put, oops, shoot, insert down here, equation, okay. Why you keep doing this underline thing to me? All right, equation, fraction. So our unit, 330 minutes per one day. And we want to get from minutes to hours, okay? Okay. Now, hopefully this is one of those conversion factors you don't have to look up. We want to go again from minutes to hours. So our minutes are up here on the top left, which means in order to get rid of it, we need to go down to the bottom right. Now, again, we want to go from minutes to hours. So I happen to know that there are 60 minutes in 1 hour. Okay, I don't even need to go up and look at that conversion chart because I just know off the top of my head how to go from minutes to hours. So again, by doing this, this enables me to go to cancel my minutes, leaving me with hours. Okay. And mathematically, what this means is I'm going to type in my calculator 330 divided by 1. That's what this first fraction is, 330 divided by 1. Okay, that gives me 330. Then I'm going to multiply that by 1 and then divide by 60. So 330 times 1 is still 330, and then I'm going to divide that by 60. And so I get an answer of 5.5. Oops. Get an answer of 5.5 hours. Is that what everybody got?
Yeah.
That's what I got, yes.
Okay. And then the next part of the question is how many seconds is this? So you could start with this point here, this 5.5 hours, and then convert to seconds, or you could go back to the beginning and go from minutes a day to seconds a day. So I just went back to the beginning. That's how I did it. Okay, and so I said, okay, 330 minutes in 1 day. And then just like before, I know I'm going from minutes to seconds. I know that 1 minute is equal to 60 seconds. So I didn't even need to go up to that chart up there. This is just one of those many, many conversion factors that I know off the top of my head. And this enables me to cancel my minutes. Cancel my minutes, leaving me with seconds per day. Oops. Leaving me with a unit of seconds per day. And again, mathematically, what this means in my calculator is I'm going to take 330, divide by 1, then I'm going to multiply that by 60 over 1, which is just the same thing as multiplying by 60. And so I got 19,800 seconds. And then if we were going to take significant figures into account, we would round that to around 20,000 seconds. It sounds like so much, doesn't it? Yet I feel like I have nowhere near that much time in my day. Okay, the next one is the one I really wanted to get to because this is one that involves multiple steps, right? We want to get from seconds, or we want to get from years rather to seconds. Okay? And there is no conversion in that table that will get you there in one step. So let's take a look at how you're going to get there, okay? So again, my starting, whoops, down here, my starting amount is 1 year. And I want to get from 1 year, okay, if this thing would cooperate, I want to get from 1 year to seconds. So 1 year is my starting amount. Now, I want to get rid of year. Okay. I do not know how many seconds there are in a year. So that is not, I'm not going to be able to go to a direct conversion. I do, however, know how many days there are in a year. That is something that I just happen to know off the top of my head. So I'm going to go ahead and go from years to days. I know that 1 year is 365 days. Okay, so this is going to enable me to get rid of my years and get to days. It gets me a little bit closer to seconds. Now, I don't know how many seconds there are in a day, and that is not a conversion factor that was given to me. So again, I'm going to have to rummage around in my head and see, what do I know? And while I don't know how many seconds there are in a day, I do know how many hours there are in a day. So I know that 1 day is 24 hours. So this is going to enable me now. We've gotten our years to cancel. Okay. So I just wiped out my years. I've gotten my days to cancel. Okay. And this leaves me with hours, which again, with each conversion, I'm getting closer to what I want, but I'm not there yet, right? I'm at hours, I want to get to seconds. Now, I don't know how many seconds are in an hour, but I do know how many minutes are in an hour. So I can say, okay, let me get one step closer. 1 hour is, 60 minutes. Okay. And again, this now has enabled me to get rid of or factor out my hours, okay, leaving me with minutes. Now I'm at a point where I can get to seconds, right? Because I know how many seconds are in 1 minute. So now we're at a point where we can use what's in our head. We know that 1 minute is equal to 60 seconds. And so this has enabled me to cancel out my minutes and get me to seconds. Mathematically, what does this mean? I mean, this is a much longer, all these other ones have been kind of nice and short, right? We've had to do 1 or 2 mathematical operations. What does this mean when you type this into your calculator, right? You want to get seconds out of this. So how do we do this mathematically? Well, what this means is you're going to take your 1 year and you are going to multiply that by 365 divided by 1, which is just 365. So 1 times 365 divided by 1 is 365. Okay. Then we are going to multiply that by 24 divided by 1, which is just 24. So 365 times 24. Then we're going to take that answer and multiply that by 60 divided by 1. Okay. And then we're going to take that answer and multiply that by 60 divided by 1. Okay, and I'm going to get a really honking large number here. Okay, and so my really honking large number, which I should have told my calculator to put in scientific notation and I did not. It looks like this. 315,36,000. So if we put commas in there to break that up a little, we'll see that we get what, 31,536,000 seconds. And then of course, if we do sig figs, right, we would probably round that to 40 million seconds. Does that match with what you guys got?
Yeah.
Yeah. So I think that the toughest part of dimensional analysis is kind of twofold. It's figuring out the layout, right? How many steps is it going to take me? And it's just figuring out how to use a table like this to find your conversion factors. or figuring out, you know, if you have those conversion, like how to lay it out, right? It's the puzzle piecing together that students struggle with the most, right? Figuring out which conversion factors do I string together to get my answer. And then after that, the easy part is the sticking it in your calculator, right? That's the easy part. So talk to me, guys. How do you feel about dimensional analysis so far?
I feel good about it.
You feel pretty good about it? Awesome.
Yep. Mhm.
How about everybody else?
This takes practice to learn how to set them up.
It does. It does. And so I definitely recommend, guys, that you utilize the practice problems at the end of the book, as well as the rest of the practice problems in this document. I'll leave it up in D2L. I posted it in the Unit 1 lecture folder. If you want more practice problems, I have literally gazillions of these, okay? So if you're at home and you've done the homework and you've done the ones in the back of the book and you're like, I really need more practice problems, please don't hesitate to reach out to me. Like I said, I have gazillions of these because it's something that we use a lot in chemistry. So I always keep on hand tons and tons of these problems. So, you know, just hit me up, say, hey, professor, can you stick another worksheet in with some more practice problems? Okay. But you are absolutely right. It takes practice.
Can we get the answers to these?
Yeah, if you finish these, you're talking about the rest of these problems here. Yeah, if you finish them and send me your answers, I'll let you know. It's not graded or anything, but I'd be happy to let you know whether you got them right or not.
Okay, great. Thank you.
Okay. Yep, anytime. And that's true for any of the extra, if you ask me for more practice problems and they're not graded, if you want to know if you got them right or not, I'd be happy to let you, to tell you that. It's not a big secret. Okay, guys, I'm going to let you go because we do have lecture tomorrow as well. Tomorrow's Wednesday, so I will see you guys at our usual time tomorrow at 9:30. Again, don't hesitate to reach out to me if you need anything. Beyond STEM 411, I've been checking in pretty regularly, so if you guys have concerns about the material, questions about the material, need any help, STEM 411 is a great way to get live tutoring help. And even if there's nobody available live, it's a great way to get, to put a ticket in, get an answer fairly quickly. So have a wonderful afternoon. Thank you so much for coming to our unscheduled session. I apologize for Zoom being out, and I will see you guys tomorrow morning.
Thank you. Have a good one.
Thank you.
You're welcome, guys. Have a great afternoon.
Bye.
And I will post this recording as soon as Zoom processes it for me.
Okay, thank you.
Guys.